Thanks everybody for joining on our meeting and in virtual land today. We got two platforms out there. Today we're going to cover some electronic cable, low voltage cable, but just kind of explain what we're going to do. We're going to do a really high overview today of the cable in the industry. This is really for more of an awareness. I do have Jacob Papp out there watching questions from me. Jacob is our product manager here at Southwire for our low voltage and electronic cable. So he's there to help answer questions. So if you got any questions, you can put them in the chat. We will be monitoring that, and we'll leave some time at the end to cover those questions. So put them in there so we can. If we don't answer them directly, we'll get them at the end and go through them. Give you a little bit of background about myself. I actually started in the low voltage industry back in 1990. It's a long time ago. So I was actually an installer for a while, designed systems, design networks. So I've done a lot. I actually stopped counting, about 25,000 locations I had designed and installed. So came up with this class really to do some basic overview for the products that are out there, the systems that are used. This category is really growing. So that's what we want to talk about a little bit today, where it was, where it's going, kind of what are the products are out there, and a couple of what are solutions that Southwire offers. So I'm going to go ahead and get started. We're 3:01. Hopefully we can get through this in time. There's a lot of material, but we're going to go really from the basics and work our way up. So again, any questions, put them in the comments. So low voltage, and that's a word we have to use lightly in the electrical industries, because that term in the electrical is used for under 600 volts. In my world, where I came from, that's the 24 volt or less. So low voltage is kind of a tricky term to use. So that's why we're kind of calling it low voltage electronic cable to help understand those applications. So one thing I want to start out, I'm going to get into really the basics of cable construction. Then we'll move into the different system types and where they fall. So let's start off here with our basic cable construction. So when we look at a low voltage cable, there's several things that you're going to find, okay? First is the jacket. The jacket is either going to be some kind of PVC or a plenum PVC low smoke, or tube or extruded covering. So again, in this class of cable, depending on the structure it's used in or the type use, you'll see these different constructions out there from PVC all the way up to tube. That's where you'll see some of the cable kind of has a loose construction on it. You'll actually see some data cables that are the extruded jackets is a little bit tighter. So you have to be very careful in stripping the cable. So that's one thing that you'll see in the tools out there. There's special strippers made for stripping low voltage cable, because the jacket is really soft, really thin, and the way the pairs come up against the jacket, it can be something where you can actually cut a pair. So that's something you have to really consider. The next thing we move into is shielding. There's either some type of aluminum foil, some type of mesh on a cable. You'll see here we have the aluminum foil there on this we call Mylar. And the next thing you'll typically see with a shield like that is a drain wire. So that's included with the shield. And the reason why is that is to drain that off to a ground. So when you have these cables, a lot of times they're either radio frequency or different type of electronics going over them. They're very susceptible to EMI, EFI out there, electromagnetic interference. And so we see a lot of times the shielding is to guard that cable from picking that up. Well, again, you've got that cable out there being an antenna. You've got to be able to drain that off to a ground so it doesn't stay on the cable and build up. So that's where you see that drain wire, in that cable construction. So then we get into the actual installation of the single pairs that are in there, or the wires. You'll either see a PVC or a polypropylene construction. So depending on, again, the cable type, that is the basic four components of what you're going to run into in a low voltage cable, electronic cable, are these components. Now, some of them will have some of these, some will not. especially the shielding when we get into unshielded twisted pair, and we'll talk about that a little bit later. So let's look at now the actual conductors. All right, there's several different conductors you'll find in low voltage cabling. First is solid. So we see two types typically in a low voltage cable. You'll see a bare copper. Again, it's less expensive to produce. Most commonly, you'll see that out there. And then we'll also see a tin copper scenario, which the reason we do that, it's in some environments where you have terminals, it's less corrosion because, you know, bare copper has a tendency of getting a sheen on it and getting a little bit of, you know, degradation of copper, that oxidizing. And with this tin copper, you typically don't get that. And so it's also better for soldering. So some of the applications we'll see out there is uses a solder connection. So the tin works better with the type solder that's used, usually silver based or tin based. So that makes better for soldering. So in solid construction, those are the most two common you're going to see done in the low voltage world. Then we move to a stranded. So when we get into a lot of audio cables, things like that, some of the data cables you'll actually see stranding. So again, we have the bare copper stranded. Again, it's less expensive to make, more flexible, easier to install than a solid. That's where we see the stranded when we need flexibility in small junction boxes or like smoke detectors where you have a small area where you're terminating and having to bend that cable in there. So that flexibility is needed, you know, terminal box. And then we have also the tin copper stranded. So again, for soldering purposes. So those are your four basic, typically you're going to see in a low voltage environment, either a solid, either with a tin copper or a bare copper, or you'll get into the stranded, which adds to the flexibility of each conductor. But again, each one of them serves their purpose depending on the system. But those are the four basics you'll typically see. All right, so let's talk about shielding. I talked about the foil earlier. So here's things that you will see addressed with the shielding. Number one, unshielded twisted pair. Okay, that's used quite a bit in the U.S. Basic phone cables years ago were unshielded twisted pair or unshielded pairs, and so there you see that there on the left. You know, really no added cost, less manufacturing time. It's pretty easy to make. Like I said, they either tube or extruded on the jacketing. The cons of this is when it's the keyword unshielded is very successful. You know, the interference from EMI or RFI, it can pick that up very easily because it doesn't have a shield on it. Typically, when you see Europe, the reason you see Europe use a lot of foiled and braided is because they have an open power system. So when you usually see data cables in Europe, it's a shielded twisted pair because their power is in open tray. So there's a lot of EMI in the ceilings in European, even in Canada. We see some in South America. So when data came along in the early 80s, they had to do a shielded cable to protect from all that open power. They don't put their power in conduit, so the data cable was more able to pick up that EMI, so they had to go to a shielded. So next thing we see, again, is our foil shield. I explained earlier. Normally you see a ground wire or a drain wire with that. I keep calling it ground wire. That's what we called it, but it's basically a drain wire. It's to be able to drain that signal that gets built up on a cable off to a building ground or some kind of isolated ground. Again, good flexibility. Your lower cost, you know, it's easy to terminate, it's lightweight. Some of your cons is mechanical strength, is that mylar in there sometimes can get broken. It's really, that's where you have to look at why we put cable in trays, so forth, in low voltage, is for that extra added protection. Again, it requires that drain wire. So each of those connections have to have some type of ground connection somewhere to be able to bleed that off. Then the next one go up, and what you see in a lot of coax cable is a braided shield. That braided shield, it really adds to the flexibility because of the braid. You don't have a solid piece of material you're trying to bend like the mylar. So it adds to the flexibility. It also really adds to the strength of the cable too, because now you've got like a braided rope around that cable. And again, that's being a shield to catch anything coming in and going out. Because when we get into coax cable, that single conductor there is really an antenna having a signal sent down it. So it's a big antenna, so that braid keeps that signal contained within that coaxial cable. One of the cons is that, you know, depending on, you see the picture here, that's a really good braid. That's probably like a 95% braid, but you actually see some of the other coax cables with a really thin layer of braid. It's probably a 40% coverage. There's a lot of air gaps in between that braid, so that allows that signal to escape. It's usually a less expensive coax cable. You'll see all this in your TV connector cord you'll buy for your home. But your higher grade, better cables, you'll see a better shield. So you see a good picture there of a good shield. But again, difficult to terminate, okay? That's one of the issues with that. You have to peel that braid back, trim it to a certain distance, to put like F connectors on, different type connectors. So it's like trimming really fine hairs. You got to make sure that you cut them all so you don't get one in with that center dielectric in there, so it can cause interference. Very slow manufacturing time because that braid is put onto a machine that braids it. So that machine can only run so fast. So that is one of the cons of this cable. It takes a long time to really make it. So let's look at unshielded twisted pair. All right, commonly used for signaling, data terminations. We saw this again in the launch of the early networks in the 80s. We saw it progress up into different signal strengths. Again, one of the things you see about twisted pair and unshielded twisted pair here is, let's explain what twisted pair does. And I'm going to kind of take a little time here. I just want to put some arrows in here to point this out. What makes a twisted pair unique? All right. From where you saw those unshielded, which was kind of like straight wires, you see each one of these pairs are wrapped around each other. That is because when we started with data, we needed a way to cancel out and push signal through it much faster. So when you have that wrap, you actually have a positive and negative signal on that cable. So your electrons being that close together, they kind of cancel each other out. So that twist is actually what helps data cable perform what it does, is the twist per foot. And as we'll talk about category cables here in a little while, but as you go up in the category ratings, that twist per foot gets more, okay? So our higher rated cables will see more twist per foot. The other thing we saw is, you see, I've got another arrow with that center divider, is that as we got into the category 4, 5, and 6, it was very important to make sure those pairs laid the same way in the cable. So that separator in the center is really a guide to keep those pairs in the same place and the same distance from each other, so we don't get any crosstalk with inside the cable. So that center divider is very, very important in your higher speed data cables. We really saw that when we got into the category 4, category 5. That's where we saw that center separator coming into play, and making sure that those cables stayed consistent down the cable, and also the distance between each pair stayed consistent. So that's your basic construction when we talk about twisted pairs. So your twist is 1, and that center divider is number 2. All right, so let's talk about now classifications. There's a lot of terms out there on low voltage cable. We're going to talk about the ratings. We're going to talk about plenum, riser, all like that. So let's first talk about the ratings. Here you'll see a chart I've got from top to bottom. And so where you see the CMP, CL3P, the CL2P. So basically this is the CMP, the CL2P, that's all plenum applications. You see the P on the end means plenum. Means it can be used in a plenum environment, means like a return airspace, or what we call ceiling, they consider return airspace. Low smoke, typically it's not going to put out toxic gases if it burns. It can be used in a riser application. But you'll see the CM and the CL. A lot of people ask what's the difference. Well, when we talked about electronic signaling data, you'll see the CM classification. The CL was used a lot of times for signaling, like audio or some type of audio application or video application. We saw it CL. So that's where you see the CM and CL classification. But again, that's an all wall. It has to be within the wall. It can be in the plenum and riser. We move into the CMR, which is riser rated, meaning it can be in a wall applications because it's closed, or it can be permitted in a riser closet where there's no circulated air to the general space. So typically you'll have a shaft within a building that's called a riser closet. That's where you'll see this riser cable that's rated for that. Because again, you're not sharing air out of that space, so that's a riser cable, and it's made to go up usually main junction points going up in the building. Then we move down into the CMCMG. This is an in-wall rated. It's permitted in family. So when we talk about residential, this is where you'll see that classification cable come in for the single-family, dual family homes. It can be used in a raceway. It can be used in riser applications. In that kind of space. When you see that G, that's for general use. So again, you'll see the CM, the CMG, the CL2, and again, that's where these can be used. So that's your kind of your, I won't say your lower grade, but more of a common application when you get into residence. So when we get into commercial, you'll see the CMP, CMR typically used. So let's talk about the actual now ratings. We talk about classifications. We see communications here, CMP, CMR, CM. You'll find that in NEC code 800. Then we get into class 2, class 3 cables. Again, you'll see the CL classification there. That gets into Article 725. That's where we get into our audio and our video classifications. Then we get into what we call fire alarm. You'll see the first starts off with an F. That denotes fire alarm, and we'll see that in section 760 of the National Electrical Code. Again, you'll see this LP, the LR, that's riser, plenum. So when you see a P on the end or R, that's riser rated. So again, those are the areas that you'll find it located in the National Electrical Code. So here's just a chart, kind of shows you from high to low. A flow chart is where we find those classifications, where they fall into. Again, basically you have what we call plenum is your high end, your medium is what we call riser, and then you get into your general purpose cable. So those show you the classifications and kind of where they fall within those parameters when we talk about, really high end cable all the way down to general purpose cable. But you're typically in most commercial spaces, you're going to see a plenum used. And then in the riser, because it's a little bit cheaper than the plenum rating because of the jacketing compounds that we have to use. You'll see that in riser application, a little bit cheaper cable, less expensive. I won't say cheaper, just less expensive because of the jacketing. And then you get in general purpose. So let's talk about actually the plenums. This is really a good picture to illustrate when we talk about plenums. We typically see a drop ceiling in a building here, and then you have the space that you're occupying in the building. You also have a raised floor down there in the bottom. And typically a raised floor has vents that has the conditioned air that will blow up into the space. A lot of times they'll use that for the HVAC ductwork because it's enclosed space and it can be used to force air into a space. Especially computer rooms, you'll see that used quite a bit. But so the plenum, again, the air is being circulated from the occupied space into the ceiling. And a lot of times the ceilings are acted as a return. So they don't want any kind of, if there's a fire up there, they don't want any kind of cable getting off of toxic gas to get mixed in with the air. So people can't escape the building, get overcome by the fumes. Same thing with the under the floor, again, that is considered a plenum space. So you have to have that plenum rated cable. And typically, unless you have a ducted air where you have a dedicated return, you have to use those plenum cables up there. If you do have a ducted return, that's where you can use a riser. You can use other non-plenum cables, but that's really hard to find typically now in commercial buildings. They use those drop ceiling as return plenums, especially and raised floors that do the same thing, going back to the chiller units. So this is where you see the CMP, the CL3P, and CL2P, basically two class ratings, 3 and 2, and then the fire alarm plenum. But that just gives you a good representation to explain when I say plenum, what is that and what does it mean? So you can see this from this illustration. So we talk about riser. Here's just a typical where we see the riser cable. This is typically some kind of communication closet. Sometimes we'll see a separate communication closet and we'll see a separate electrical, or sometimes you see them combined. This is typically a core in the building, core space around on the outside edge. Typically it's in the core around the stairwells, the elevator shafts, and they use this to go from the bottom of the building up, typically computer rooms, especially multi-story, same company buildings. They'll have a computer room or something at the bottom, or where the service comes into the building, and they'll go up that riser closet to take it to each floor and distribute it through some kind of router or something like that. So this just illustrates a good illustration of what the riser looks like. But again, that space is usually conditioned by itself in that room, because especially if you've got electronic equipment like routers, servers, so forth. That space is not circulated air into the common space of the building. So that's why you get away with using just the riser cable, because it is now separate from the other airspace. So let's look at, when we talk about the low voltage electronic cable, where is that used? These are the areas we're going to talk about today. So we're going to talk about security. We see these applications in the security. We also see it in access control, meaning the door readers in your building, door switches, door releases, fire alarm. We're seeing a bigger jump now into the lighting control. We'll talk about that a little bit more. Data cable, of course, has been around for 30 plus years. Now here's a new thing, PoE. You'll hear that term, but that's called power over Ethernet. So we'll talk about that here in just a minute too. T-stat, which is your thermostats for your buildings, typically in your home, your thermostat, that we'll call T-stat wire. And then building management controls. That's another thing now we're starting to get into, is controlling a business, the environment, devices through a smart building. Here's smart building term thrown around. That's where we get into this building management control cables. So let's dive into this and talk about each one of these categories, kind of giving you a basic about the cable construction, where it's used. So now let's kind of dive into each one of these areas. So first, let's talk about security. Typically we see that CL classification there because it's some kind of audio or video signal that they're using. You'll typically see gauge sizes in this area from 24 down to 12. Depending on the system. The more modern systems, you'll see the smaller wire used because less data or voltage signals having to be transmitted with it. The conductor types are typically stranded. You will see some solid in this, but you see a lot of stranded in this because of flexibility, because you see that control box there, bringing wire in. It's a little tight space to make the turns to the terminal, so that flexibility is needed. You do see voltage range in this. Again, most of your low voltage cable is 300 volts and less. Anything above that is goes into the electrical world. So in the low voltage world, we typically deal with 300 volts and less. So you see the 24 volt, 150 volt, and then the older systems, sometimes we'll see 300 volts. But most of the more modern now security systems, you'll see it down in that low voltage range, that 24 volts. And that's where we'll talk about PoE. That's where that's coming into play into this world. So those are your cable classifications you will see for security. And again, I use for either touch stations. Cameras can be now into the PoE range. So you start seeing a hybrid of cables being used in the security world, from older systems, which were coax, for the old cameras, to now digital cameras using a twisted pair cable. But typically for your control panels, you'll see these ratings on those touch pads. So let's talk about access control. Try not to get tongue tied here. So access control, this you'll see by the pictures here is where we talk about access control. This is where you'll see the magnetic strikes up here. You'll see the door readers or either the door strikes. So this is typically, we see the CMR the CL3R, CMP, sometimes we see plenums, but a lot of times this access control cable is in the wall or in some kind of guarded space because, again, it's a part of the security. So they don't want easy access to this cable so people can't hack a door. So typically we see plenum rated in this environment. Components we'll see from 22 gauge down to 18. Depending on if it's taking power to the door, that's where we'll a lot see the 18 gauge cable. Typically we see stranded in this environment, again, because we have terminals that the cables are terminating on screw terminals. You will see shielding in this, like foil shielding versus your braid. And then sometimes you see it with no shielding on it at all. Most of the rating in this is a 300 because typically they're taking power to energize those magnets on that door or either energize that door strike there to be able to unrelease whenever it's activated by the card reader. So when we look at this system here, there's a good picture there at the bottom. We call, the term is called Siamese cable. Basically, we've taken like 2 or 3 cable types and put them into one single jacket. We see this commonly done in this way because it saves on the support structure needed to take that cable from the security or access control point to the door location. And when we look at this door right here, number one, we'd have to have a cable for that reader. Number two, we'd have to have a cable for either that door strike or that mag lock. And typically we'd have to have some kind of emergency bypass on the inside. So if there's an emergency, there's a release switch or a door switch, or we have to have a proximity or IR sensor up the top to pick up that motion in front of the door to release the door to let you out. So we're talking about there's 1 cable there, 2 cable there, possibly 3 on the wall, the 3rd one or 4th one in the ceiling. So that's where we see at these access points, having those multiple type cables going to that, and that's where this, what we call the Siamese cable, comes into play and really saves contractors time and money because it's a single cable versus having to support 4 different cables going to a point. So access control here is one of our boxes we have. We have these available in what we call a reel in a box. For years you saw this come on spools in the industry. One thing that Southwire did was took that spool and we put this spool in a box that's easier to tote. You don't have to have a reel stand to set those reels up and use that reel. These boxes have a frame inside of them, so the actual reel is sitting up off the bottom of the box. We had a lot of manufacturers would just throw a reel in a box and it would drag on the bottom of the box and very hard to pull out. You drag the box all over the floor. And so now having that frame inside there, that reel turns very easily. You don't drag the box across the floor. You'll see the wide mouth right there, so it keeps from any kinks happening of that cable coming off of that reel, so it can go from left to right across that box and off the reel. Another thing we do is we color code our labels. So you'll see this one right here at Sound and Security is red. Is one thing we do for cable management on the job, and these are the little things that I really like, is that they're going to be all like white boxes. You'll see communication boxes out there. It's very hard to go up there and read the label to see what kind of cable it is, especially if you're on a job that you got 5 or 6 different cable types. One thing Southwire does is we color code that label depending on the system. So like you see Sound and Security here, red. We'd have different color for like data. For maybe our coax, we'll have a different color. So on the job, just visually looking over, you can see by that label what type cable it is, especially if you got all stacked together. It's just easy to manage by those colored labels. So that's some of just the little things we do to help manage this cable on the job site. Another thing too is jacket colors. We can make these in different color types. So again, when we talk about trying to segregate these systems on a job, contractors a lot of times will like to have these jacket of the cable colorized to the system color. I know when I was at the Verizon GTE, we would do that because I could look in the ceiling and no matter what contractor I had in there, they could identify the color code depending on what system it was. We had a color for data. We had a color for at the time, our telephone system. Security cable would have a certain color. Door access would have a certain color. So it helped us manage the ceiling and what cables were what. So when we looked up there, We could tell what cables went with what type of system, keep them together, keep them separated. So if we ever had to do any changes, it was easy to identify. So you'll see in the data world, a lot of customers, especially engineers, like to have a specific color to a system. And so that's something that we can do for you. We can custom color these cables depending on what you want. Then we get some of these universities that really want it the school colors. I actually did a job one time at Notre Dame, and they wanted it all green in their Notre Dame color. So you'll see that actually pop up too. All right, let's talk about fire alarm. Fire alarm cable, you'll see typically the rating up there is FP, meaning for fire. You'll see that the first letter there denoting fire. Either you got your plenum or your riser rated. Conductor size we see in this, typically you see a 2-conductor and a 4-conductor cable. And it ranges from, it actually can go from down to 12 up to an 18, depending on if it's an annunciator. What I call annunciators are the flashers that you see, the strobes that actually let you know there's a fire, down to your pull stations here. Sometimes can be a 4-wire. Some of the smarter devices now are requiring a 4-wire because they're actually monitored and polled. The system actually they poll the units to make sure they're functioning. So we see everything from stranded to solid in this scenario, depending on what system. Again, there's so many different fire system manufacturers out there is what they specify. You will see a lot of shielding in this because, again, this is a critical system in a building. They don't want any interference setting off a fire alarm or causing something not to work. So you will see shielding in this because you're running power over this wire. And so they don't want any of that to bleed off and causing a problem. Most of the time you see the rating at 300 volts. One of the things that we do different is now in the last couple of years is you'll see in the bottom right picture, we're actually packaging this in a coil pack in a barrel. So coil packs we introduced into our electrical world about 5 years ago. We are now making our coil packs for our fire alarm cable. Mainly our 2-conductor, and then our barrels will go from a 2,500 foot, and we have 5,000 in Jacob. I think we do also have a 10,000 foot, but you can go on our website there. And so this right here really helps because most of the time you typically would deal with reels in the fire alarm world. So you have to have somebody manning that reel as you're pulling cable, make sure it didn't overspin. So now with this application with the barrel and coil packs, that's a single person operation. That coil pack has a little bit of resistance to it. Nobody has to man that. You can lay it on the floor or you can use our coil pack carts, but you can just lay it right there at the where it's going in the system and have it pull out. It's not going to overspin because of that back drag. The nice thing about the barrel is that if with those multiple footages, if you've got a really large building where, let's just say a warehouse, where you have really long annunciator, indicator runs, typically go up to 1,200 feet, and those are daisy chained. So a lot of contractors like to pull one wire the whole length, and they will come along and tag the strobes along that. Well, your reels were 1,000 feet, so you ran short, and you had to take another spool and get that other 1,200 feet out. Well, these barrels now allow you to have that long footage, so that I can do multiple 1,200 foot or 1,000 foot runs out of that barrel, and not having to splice or use partial reels and keep up with all those reels. So really it's a time saver and it's a money saver because you're going to cut down on your waste. So again, that's some newer applications that we have in the fire alarm world is those coil packs and those barrels. So right here, this gives you a sheet that you see that our coil pack and a barrel. So we have from our 22-inch, our 30-inch, and our 42-inch barrel. Again, this is designed to increase productivity and on the job site. We talk about labor shortage out there. A lot of contractors are not aware of this. Y'all are out there on the call today. This is a moneymaker because, again, you're going to cut down on waste. Single person operation. These barrels, even if it's the big 42-inch barrel with our cart, you can move that barrel around with one single person. The coil packs are easy. They got a handle built in the center. You can tote them along and lay them down. You're not worried about having to have a reel stand for your reels or toting a reel with two hands. These are easily picked up with one hand and toted. So again, a great solution, a great package, and again, it just really cuts down on your scrap and adds to your productivity. So I do have a little video here, so I want to show. So we'll see this in action. So we'll see how this plays. So Beth, y'all let me know if it's too jerky on the end, and I'll stop it.
Okay.
You'll see here that I've just hooked this up to a gripit. It's one of our gripits that we have in our simple rope. And this is a simple guide that we have from Madison Electric. This is a roller. It goes on the faceplate, keeps it from dragging. And I've got an XD1 here that I'm going to pull the cable with. I can pull up to 90 feet a minute with this, depending on your drill speed, the drill you have. You can watch this go right in the box. Starts, person walks away, then they're pulling itself. I love that little roller panel so it keeps the cable from dragging, because again, we're typically dealing with soft jacketed cable, low voltage cables, easy to tear, easy to rip. That's why we see a limit of 25 pounds on pulling. The good thing about the XD1 and a drill with a selector guide on it, you can turn it down so you won't exceed that 25 pounds. It'll clutch out when you hit that 25-pound mark. You won't damage the cable. So here's our barrel. Again, using the XD1 to pull that. You get this started, and Johnny just walks away. Now, this is a tripod system we have on a barrel. We do have a barrel cart, but this is, we didn't have a really good video showing this, but this is something you can use to sitting that barrel on the floor. You don't have to have the cart, and it pulls right out of the barrel. Again, nobody's having to sit there and man that. So you can imagine this as the fire alarm panel pulling out to your locations and just doing multiple pulls out of that barrel. So that's just a little short video. Beth, did that play all right on your end?
Yeah, it did. It was great.
Great, great. So just wanted to show that, to see that in action, to understand what the coil packs and barrels were, and seeing that it doesn't take another person to man those packages. So good. I'm glad we're introducing that now into low voltage cable. So let's talk about some new cable that's really been reintroduced. It's our 2-hour rated alarm cable, fire alarm cable. So now we're seeing some of the, a couple of years ago, probably over now 3 years ago, they went through and changed some of the certifications requirement on fire rated cables, kind of turned the industry up on its ear. So a lot of people had to go back and recertify cables. So one thing we got rated is now a new is a 2-hour rated fire cable. You'll see it here, and this is actually where they did the fire testing on it to make sure it would pass. You'll see the FLR, plenum rise rated, and the UL 2196 rating on it. You'll see this from a 14 gauge up to an 18 gauge. Again, it's solid, no shielding on this, in a 300 volt range. So this is what we call a dedicated circuit or 2-hour rated cable, but we see this here in the fire alarm use. So again, when you're required to have that 2-hour rating now in a building, we do have a product now that can help you meet that demand in a building. So we're seeing those ratings go up in the industry, especially since the things that went on in the past I won't mention, but now they want longer rating on cables, so systems can be active even in an environment where you got a high-rise fire or whatever. These systems can last a little bit longer to get people out of the buildings. So let's talk about lighting control. All right, so that's another category we're seeing out there is lighting control. You'll see one cable down here is typically used at the gray and the purple. We see this a lot now. We call it, you hear the term 0 to 10 out there. But lighting control, you're going to see the CMP, the plenum rated in this, because typically it's going to lights that's in an open space from a 16 up to an 18 gauge cable. You'll see it's a 2-conductor, typically stranded. And we have those 2 colors that designate that it is a lighting control with your purple and your gray. We are doing this cable, this control cable in our MC product and also in a Romex. Again, lighting controls, the newer things you're seeing is 0 to 10 or PoE, but we have several applications out there for cables to be used in a lighting controlled environment. Actually, we're doing a class in a couple of weeks with our IC chapter, and I think about 5 or 6 different cable types depending on the lighting control system that you're using. But this is the most one common one you'll see here, the 2-conductor with the purple gray. But again, we have a solution for you in this arena, and we also have some unique with our PCS cable, our power control signal, where we have that control signal in with the power. And it's already rated. The jacketing gets you the separation between the power and the signal cable. But now we're offering that in a Romex product because we're seeing a lot of, like in California, most homes now have to have some kind of lighting control in their home. And so we're seeing that Romex with daylight harvesting, you know, aux sensors, that kind of thing is required out there. And we're going to see that more stringent come across the country. So we do have an application for that. So lighting control is another place we see these low voltage cables used. Then we talk about data. This is where we get into the unshielded twisted pair cables. We will sometimes see shielded an environment where you're in close proximity to the motors or some kind of electrical interference. They may even do conduit to use unshielded twisted pair. But typically you see a CM rating, CMR, and the CMP. Remember that CM is for communication electronic signaling. And we'll see the P, the R, and just the general use there, ratings on this cable. Typically, you see a 23 and a 24 gauge cable. For years, most of the category 3, 4, 5, or 24 gauge. As we're going up in the category 6 range, and some of the 5s, we're seeing now this 22 gauge, or 23 gauge, excuse me, come into play. Because we need we're pumping more signal through there, so we need more bigger cable size to get the signal out there, and the twist per foot. Again, you're going to typically see this in a 4-pair configuration with your blue, orange, green, brown conductors. You will, like I said, you will see full shielding in this. Whenever you need a shielded pair, typically this is where you see full shielding. We don't see typically any braided in this. This is a full shield with typically a ground wire associated, or the connector can actually hook onto the foil itself and use the foil to ground that off. Again, you see it's 4-conductor scenario, and you see their gauge rating from 23 and 24 gauge cable. Again, all twisted pair because of that signaling, the positive negative on the signaling. But now let's talk about power over Ethernet. This is the new thing we're starting to see out there, and PoE is really, I want to say 10 years or so into the market or so. We saw it in early 2000. We take a jump. You'll see the rating has a CMP, an LP, 0.5 amps, the CMP there, and LP, 6 amps. So what this is where they're actually running power. When we talk about power over Ethernet, is they're using one of those conductors to push a power to the device, like a camera, Ethernet switch. We'll see things like that, or equipment. Now with the electronics now not requiring much voltage, is most times you saw little network switches at your house. The little transformer was taking it down to 12 or 5 volts to run that. So they found that now with twisted pair, we had a pair that was not being used. Typically the blue pair was used for communication guys, phone guys, and originally starting out, that's the pair color they used because that was a center pair color. Then when the Ethernet 10-base-T came along, I hate to say it, I was there when it was ratified, the 10-base-T is a signal, but they used the orange and the green pair for the transmit and receive, so we needed 2 separate pairs. So that left a lonely brown pair by itself not being used. So now when PoE came along, now PoE has now used the brown pair. It's actually got a use now. So now we've got a pair that can be used for the power. But sometimes you'll see the different orange and green depending on the system used. But normally we see data signal, Ethernet signal was around a 5 voltage range when it was coming out of a switch or router. And so that 5 volts now, instead of pushing a data signal, they could use that to power a device. So that's kind of really the birth of where the PoE came from, just to kind of give you all some history. So again, Southwire is now introduced a PoE cable. We do have two different variations of this. You'll see that, look at the twist per foot. It's a lot on PoE because again, this is a higher rated data cable in your 6 category range. You're going to see that middle membrane there to keep the separator. Very, very important when you're dealing with a higher speed is to keep those pairs consistent throughout the length of the cable. That helps on your crosstalk from cable to cable. Again, and you'll see typically 23, you see it's a little bit larger, has a little more space inside to space those pairs from each other. So typically you see the PoE cable and category 6 cable a lot larger than your typical category 4 or 5 cables. It's a much larger jacketing, a little bit thicker jacketing. So you can see a physical difference when you compare the two. When you see a PoE and category 6 cables, much larger. But again, we see this PoE used now in security. We see it in lighting. So the talk of the town is, eventually we're going to go to low voltage lighting, and it's going to be around with PoE. So once we see them ratify what voltage they're going to use, you'll see this growth much more, but it's coming, okay? I'm having several conversations with trade organizations around this, and who's going to do the work, low voltage or electricians. So lighting will be ran over this cable. So we'll see lighting systems ran by power over PoE cable. Sensors, all your aux sensors, daylight harvesting sensors, all that can be now ran with this cable because again, the voltage range in that 5 volt less to run them. You'll see that used HVAC controls. We see a lot of HVAC now are smart units. They're using a data signal to communicate to that sensor. Those smart buildings are using sensors to see if somebody's in that space to adjust the air. So that's where we get into that access control. And we talk smart buildings. You're going to see PoE used quite a bit in smart buildings to see where people are, see what to turn off, monitoring power draw in buildings, amperage. There's all kind of stuff we're going to see in these smart buildings that they're doing with it. Again, this is going to be a cable that's going to be used in so many different categories. You're going to see it explode. I had a presentation this year about 5G and how this PoE now with 5G becoming more prevalent out in the world today. We're going to see holes with weather monitoring station, Bluetooth and Ethernet, and the lighting all ran from a PoE cable. No power going to it. All PoE running those systems, weather monitoring, all that. So again, we're going to see a big explosion in this market. That's why Southwire has got 2 products we're offering out there now into this arena. Thermostat wire, been around for a while. So you'll see this is where you see a thermostat at your home, but you'll see a CL rating, meaning that was a signal or video, that CL rating. You'll see the 2 there, class, and then we get into from a 18 to 20 gauge cable. We'll see what's grown in this is you'll see here from solid connector. It's gone from the old days of the 2 and 4 connector for your house thermostat now to a 12 conductor. A lot of I told you earlier about the thermostats being a lot smarter. There's more electronics on HVAC units now, especially in the commercial world. And we're seeing this multiple conductor now going from thermostat back to the unit for it to monitor different things and different signaling. It's having to go back to the unit. So we saw this pair, or not pair count, but the cable count go up in this thermostat wire from what traditionally you would see used in residentials. A lot of commercial we're seeing now required an 8 conductor and a 10 conductor cable, and a lot of these new HVAC systems that have a lot of electronics on the unit that want to communicate down to the thermostat, adjusting humidity, all that kind of stuff, monitoring all kinds of different systems at that access point. So again, you'll see this in a range of 150 volts because again, it's just taking a signal down to that thermostat to read what's going on in that zone. So you'll see that again, that pair count's very high in this, but again, thermostat wire, none of the low voltage category. So let's talk about building management. This is another buzzword of the year. Is now we're seeing a lot of building management controls, smart buildings. You see the CM rating, the CL, the CMP, again, plenum, gone from your class 2 to a little bit higher class 3 rating. So you have a little bit longer rating on that cable. You see an 18 to 22 gauge in your gauge sizes. Conductors in this can be all kinds of different things. You've got your stranded, you got stranded, you got your copper, you got solid, TC1 pairs up to 4 conductor. You'll see there one with a full shield, 2 conductor with a drain wire inside and out. It's depending on the building system. Okay, so again, this wide range of cable in this area right here. But again, these monitor, when we talk about smart buildings, I talked about humidity, you talk about temperature, aux sensors. You know, it's helping dim the lights when there's daylight coming through there. So daylight harvesting monitoring, what's the light level. So help just to all the way down to, you know, the smart screens and touch stations and where people are. Well, now we're seeing you know, face recognition stuff in this for security on airports. So again, this building management control is buildings are getting smarter. This is almost becoming a commonplace now in construction. All this monitoring in a building, and so we see these building management controls out there. So again, we have a lot of cable, but again, you're going to see things with like this purple here. Again, remember the purple in the lighting control. This purple means it's some kind of control system. So you'll see that drain wire in the center and on the exterior. So keeping the interior drained off, don't let it get out, and nothing to get in. Okay, on this, because again, these could shut the lights off in a building or HVAC, turn it off. So, and these are critical systems within a building. One thing I want to leave you with, this is actually a poster. So if I've got any schools out there or training facilities, we do have a poster that kind of shows all the different cable types that we do make. Nice QR code on the bottom there that you can scan. It will take you to a place on our website, so you can look up all these different cable types. So you'll see where we broke it in the CAT TV, the CCTV, closed caption TV, special applications to HVAC, to the audio video world, to the security world, that datacom world, and the fire alarm. So shows the cable types that we make and what category they fall in. So this just gives you a good representation of seeing how many cables there are just in this world, and depending on what systems you're using and what cable type falls in there. So again, this is just a high-level overview of the system. So I've got about 8 minutes left. And so, Beth, I am going to turn it over to Jacob and see if we've got any questions out there.
Yes, actually, quite a few questions coming through.
Oh, good.
I know we had a lot coming in earlier around Canadian questions and how the FT4 and the FT6 ratings relate to this. The only thing I could really speak on currently is the FT4, so I know that we do a lot of FAS, and the FT4 and the riser rating are fairly similar and usually tested together. The FT6 can get a little bit tricky as far as it relates to plenum, but this is something that I'm looking into currently to see how it does relate, and I'm going to get back to that individual who asked that question with a more firm answer on the FT6.
Yeah,
also, Bill, I don't know if you're coming on that or not.
No, so in Canada, the data, I'm going to tell you, I'm an American data guy. The only thing I can tell you about Canadian on data is load rating and cable tray. So that was the experience I had with data in Canada. The most applications, I can tell you, if it met it in the U.S. standards, it was okay, you know, back in the plenum world in category 4 and 5. Now we're into the 6 and the PoE. There may be a few changes. I know in the data world in Canada, it was load rating and cable tray that we dealt with up there. But I don't know about this new rating. We'll have to check into that, Jacob. That's one thing. I'm not an expert on the Canadian data, especially the newer stuff.
Okay. The other question was the 2-hour rating has the Canadian approval, and it does. It has the ULC S139. So if you have if anybody has any questions with that or needs a spec, please feel free to reach out to me via email. I can send you that information. And let's see. I There was a question around a PoE cable and kind of the different ratings for lower than 300 volt. I mean, the way that this is measured, there's an LP listing, which is UL's standard, which Bill mentioned. It's that 0.5 or 0.6 amp measurement, and there's also the IEEE 802.3 AF.
I think it's AS. I think it's 3AS.
And BT. Those are also the TIA, EIA standards, which these qualify depending on the construction you're looking at. And there was a question around PoE cables being used for emergency power, and asking if they need something like the UL 2196. This is something which has come up quite a bit, actually, as of late. I know that there's been a couple of conversations around, if there's a battery power solution or what exactly, we could do with this to ensure that the emergency lighting will work. I'm not aware of any PoE product that has that 2196 or something similar. I know that there's, as far as this data cable in general, I don't think there's any UL listings out there for it. But this is something that, has been discussed, and I know that people are, looking into how they could accomplish this, but not currently that I'm aware of, at least.
No, I've not heard anything. Most of all the buildings I've seen with a PoE lighting system, they still had to require the battery, either wall packs or anything like that. Lighting manufacturer would have to see. I have not seen one to this yet that had a battery pack for PoE. So, okay. But again, they're all over the place right now. The problem with the PoE and lighting, just so everybody know, is the voltage. What are they going to settle on the voltage? That's the big dilemma out there right now. Is it going to be 5? Is it going to be 12? Is it going to be 24? So that's one of the big holdups, I think, right now, my opinion, is holding up that PoE lighting, is what are they going to standardize on?
Yeah, then the last question is, does building management control doors? I guess not necessarily. I think the access control cable would be your door control. I know that a big part of that, which I don't think that we could do with a lot of the type of signal type products that we have with the building management products, is going to be that door magnet. I know that we need to a little bit of a bulkier product to power that. So the building management, no, but access control would be filling that void for it. And that's all the questions.
Okay, great. And I'll just say that I have been looking at the YouTube feed and the comments, and we do not have any questions on the YouTube feed. Okay.
Well, again, this is a world, and this is why it's very hard to do a presentation. We can kind of cover the cables we have, but when you get into this low voltage world, depending on the system, like Jacob says, the door manufacturer, depending on what strikes, the PoE lighting system, depending on the data system, the alarm system, you're going to have that manufacturer specify a certain type of cable to be used. And this is where we get into communications. It's tough. There's not one fix all for everything unless we can get somebody to standardize on it. So that's been the problem in the low voltage world for a while. You would agree, Jacob? It's been driven by manufacturers and systems.
Oh, 100%. I mean, specifically talking about the power over Ethernet, I feel like the technology's there. It's just the applications have to catch up.
Yeah, it's actually, it's funny. We're doing that lighting control thing in Atlanta in a couple of weeks, and, a couple of cables, I won't say, there's a certain manufacturer out there, and that's got the nickname on that cable because that cable only works on their light. And it's a certain range, certain size, and everybody's having to make that one just for that one system, starts with L. And so you see that happen quite a bit in this world. There's a specific cable type that they want, and you have to make it just for that system. And then when you move to different manufacturers, something different. So we see a lot of that in these systems. All right. Anything else? Any other questions? Well, good. We made it within an hour. 1 minute to spare. That's good.
Yeah, I don't see anything else, Bill.
All right. Well, thank y'all for joining today. Again, this was just kind of a high-level overview. If you've got some other questions, Beth, I don't know if you've got a screen up there. You want to throw our email addresses up, and I'll stop sharing my screen and you can grab it. And
Actually,
I don't know if you have a slide or not.
I didn't have a slide, but I am putting y'all's information into the chat window, so
Okay.
Everyone can see it there.
Again, and Jacob is probably the expert to turn. He's dealing with this every day, you know, with these specialty standards and the testing we're trying to meet on all this. Again, our PoE just came out, a month ago, Jacob, 2 months ago, really launched it. So, you know, fairly new. Yeah, January. So, yeah, well, we're behind. So, yeah, about 4 months ago, 5 months ago. So, yeah, again, it's keeping up with the market, but we wanted to make, because again, there's so many different specs to kind of meet out there. That's why we have the two classifications. That's 0.6 and 5 amp. Was it 250 megahertz and what's the other one? 500, I think.
250, yeah, 250 and 550.
550, yeah, 550. So that's the data rating on it. So anyway, we have that available for you.
Great. Hey, Bill, there was someone asking about when your next class is. So I wanted to tell everybody that you can go to southwire.com/services and then click SSU. And when you get on our page, just click virtual training and you can click on that. And then you can see all the upcoming courses that we have for you guys.
Yeah.
And I put that link, or I just put the link in the chat for you guys. Well, not the link, but how to get there, like the navigation stream.
Okay. Well, again, thanks everybody for joining. If you got any other questions, like I said, they got all our emails out there. Shoot Jacob. No, he said either one of us will email. Again, there's and turn to your local rep, Southwire rep, or our distributor there in the area. I mean, that's your local help that can help you out on these job sites and talk about certain things. Because then, you know, customizing, Jacob, you know, we can do a lot of customization, especially the access control, you know, depending on what cable combinations you need, color. So that's really about taking advantage of that. I see quite a bit of that in the data world, custom colors and custom combinations. So we can do that for you.
Bill, one more thing I want to tell everyone is that I'm going to go ahead and send a follow-up email to everyone, and I'll put some of this information in there. Okay.
Okay. Thank you. Again, hopefully, there's any comments on this y'all want to see in this class. We kind of created this for some students, and we just wanted to show it here to just kind of give some people a good high-level overview. So if anything else you want to see in this presentation, let us know. Okay.
All right.
Thank you.
All right. Bye-bye, everybody.
Bye-bye.
Thanks for being with us, Jacob.